Good morning everybody. This is the last class of P block elements, that is group 18 elements. After this class we will study the next chapter. The name of that chapter is solution and colligative properties. So in this class, see the remaining part of Z18 elements. So chemical properties of group 18 elements, that is noble gases. We know the noble gases cannot react with other elements due to completion of octet. Hence all noble gases are the chemically inert or chemically inactives. But see some chemical properties of Z18, that is noble gases. First, reactivity towards hydrogens. You know, hydrogen atom can react with G16, G17 to form the hydrides. But Z18 elements cannot react with hydrogen atom and does not form the hydrides. So simply it does not react with hydrogen. It means what? Noble gases cannot react with hydrogen due to completion of octet. Then second chemical property, reactivity towards oxygens. We know whenever the oxygen can react with any elements, that may be G16 or 17, to form the corresponding oxides. But noble gases or Z18 elements cannot react with oxygen due to completion of their octet or the inert gas. So it does not shows reactivity. It does not shows reactivity with oxygen. Noble gases cannot show the reactivity with oxygen atoms. Then third chemical property, reactivity towards halogens. How to form the reactions of noble gases with halogens? In noble gases only krypton and xenon can shows the reactivity with halogens. Krypton and xenon directly reacts with fluorine. To give the fluorides. What it shows, whenever the krypton or xenon can react with halogen, that is the fluorine, to form the corresponding fluorides. For example, xenon reacts with fluorine at 673 Kelvin temperature, that temperature is must, and 1 atm pressure to form the xenon fluoride. It is the xenon fluoride or xenon difluoride is formed. So this is the reactivity of halogens with noble gases. Then see the next chemical property, reactivity towards metals. Reactivity towards metal. Like to the hydrogen and oxygen, metals cannot also react with noble gases. So noble gases does not react directly with the metals. It does not show the reactivity with metals. So all these are the chemical properties. Only chemical properties can occur in halogens. That is the what? Fluorines. Then see the compounds of xenon. How to form the compounds of xenon? First compound, xenon fluoride. First compound is the xenon fluoride. How to prepare that xenon fluoride? See the preparation method of xenon fluoride. Xenon fluoride is prepared by direct reaction of xenon and fluorine. When xenon and fluorine directly reacts with each other in different ratios at different conditions, then it forms the xenon fluorides. First example, when one xenon can react with one F2 molecule, 1:1, one xenon, one fluorine molecule is taken in sealed nickel tube and heated at 400 degrees Celsius temperature to form the xenon fluoride, especially that is the xenon difluoride in sealed tube of nickel at 400 degrees Celsius. Second, 1 mole of xenon can react with 2 mole of fluorine, 1:2, ratio is 1:2. Then which is taken in sealed nickel tube, and heated at 5 to 6 atmospheric pressure. It requires the 5 to 6 atmospheric pressure, then gives the xenon tetrafluoride. Next, 1 mole of xenon and 2 mole of fluorine can react with each other in electrical discharge minus 80 degrees Celsius temperature, that is very much low temperature, negative temperature, to form the xenon tetrafluoride. Last, 1 mole of xenon and 3 moles of fluorine can react with each other in electrical discharge at a low temperature, that is variable low temperature, then it forms the xenon hexafluoride. So all these fluorides of xenon can form when reacts with xenon and fluorine with each other at different conditions and different ratios. Both ratios are different and conditions are different to produce the xenon fluorides. So these are the preparation methods. Then see the chemical properties of xenon fluoride. First, hydrolysis. When xenon fluoride is dissolved in water, then it forms the hydrogen fluoride, HF, with separation of xenon, and oxygen is bubbled, given out. That is the hydrolysis process of xenon difluoride. Then second reaction with phosphorus pentachloride, PCl5. When xenon fluoride reacts with phosphorus pentachloride, then it forms the xenon fluoride phosphorus pentachloride is the adduct, is the addition product which can react with each other to form the combined product that is called as xenon difluoride and phosphorus pentachloride. So all these are the xenon fluorides preparations and chemical properties. After that, see the xenon tri oxide. How to form that xenon tri oxides. Xenon Tri Oxide. Xenon Tri Oxide. First of all, See the formula of xenon trioxide, that is XeO3. How to prepare xenon trioxide? Preparation of xenon trioxide. Generally, that xenon trioxide XeO3 is prepared from xenon tetrafluoride. When xenon tetrafluoride is dissolved in water, then xenon trioxide is formed. When xenon tetrafluoride dissolved in water to gives xenon trioxide. Very simple process. You may take the xenon tetrafluoride and dissolve in water, then we get the xenon trioxide. How? XeF4, that is xenon tetrafluoride, can dissolve in water. Xenon tetrafluoride is taken and dissolved in water. Then it gives 2Xe, that is separation of xenon. 2Xe separation of xenon. After that, XeO3, xenon tetraoxide, XeO3. Then what is remaining? HF, hydrogen fluoride, and lastly oxygen, O2. Xenon tetrafluoride dissolved in water to form the xenon trioxide. Then balance the reaction. For that purpose, we will require 3 moles of xenon tetrafluoride, 6 moles of water, then 2 moles of xenon here. Then actually 3 moles, 1 here, that is 3. Then HF, how much HF? 12 HF and half O2. So xenon trioxide is prepared by these ways. So this is the xenon trioxide. After that, Oxy Fluorides of Xenon. See the Oxy Fluorides of Xenon. How to prepare that Oxy Fluorides of Xenons? Oxy Fluorides of Xenon. Xenon can react with oxygen and fluorine to form the oxychlorides. So see the xenon can forms following oxychlorides. Xenon forms following oxychlorides. That is, which are that oxychlorides? XeOF2 xenon oxy difluoride, then XeO2 F2 second oxyfluoride of xenon, then XeO2 F4 O2 F4 etc. Number of xenon oxyfluorides. Xenon forms following xenon oxyfluorides, that is XeOF2, then XeO2 F2, then XeO2 F4 are the number of oxyfluorides of xenon. Then see the preparations of xenon oxyfluorides. Preparations of xenon oxyfluorides. How to prepare the xenon oxyfluorides? For that purpose, you have to require the partial hydrolysis of xenon fluoride. First partial hydrolysis of xenon. The partial hydrolysis of xenon fluoride gives different oxyfluorides. Gives different oxyfluorides. First of all, take the xenon fluoride which undergoes partial hydrolysis, that is means to add in water. Suppose we have to take XeF4 and dissolve in H2O at 80 degree Celsius temperature. Xenon tetrafluoride is taken and added in water, that is partial hydrolysis. Then it formed the XeO, that is xenon oxygen, and F2 plus HF. Likewise that xenon oxyfluoride is formed. Is the first preparation method of xenon oxyfluoride. Again, xenon oxyfluoride is prepared by second phase, that is hydrolysis of xenon oxyfluoride. Hydrolysis of xenon oxyfluoride. Xenon oxyfluoride gives xenon dioxyfluoride. For that purpose, see the reaction. Suppose XeOF4, xenon oxyfluoride, is dissolved in H2O water that undergoes hydrolysis to form what? XeO2F4. XeO2F4, and that is 2HF. 2HF here, F2. Xenon oxyfluoride is dissolved in water to form the xenon oxyfluoride and hydrogen fluoride. So all these are the preparation methods of xenon oxyfluoride. After that, see the structures of xenon compounds. How to form the xenon? Their compounds with different elements. That is, compounds of xenon and its structures. That is, structure of xenon compound. Structure of xenon compounds. For that purpose, firstly take the formula of that compound, then its oxidation state, and finally its structure. First compound is the xenon difluoride. XeF2 having the oxidation state +2. Why? That is, only one xenon can link with F2, that is 2 fluorines. So oxidation state is 2. This xenon fluoride can form the structures likewise that. For that purpose, the xenon is placed at the center. Xenon is placed at the center, which is linked with two fluorine atoms. One fluorine and this is another fluorine. Both the fluorines are linked with xenon to form the straight line structure or linear structure, and remaining electrons are formed in the forms of lone pair. Lone pair. This is first and this is second, and remaining is the third. So this is the linear structure, linear chain structure of XeF2, xenon difluoride. After that, see the XeF4, xenon tetrafluoride. One xenon atom can link with 4 fluorines, therefore its oxidation number is +4. In which one xenon, that is central atom, can link with another fluorine atoms. Likewise that this xenon is the central, can link with 4 different fluorine. One fluorine, that is second fluorine, is the third fluorine, and last fourth fluorine. 4 fluorines can link with xenon to form the square planar structure. Square planar structure. Likewise that. So this is the square planar structure, and remaining one electron in the forms of lone pair. That is square planar structure of what? XeF4, xenon tetrafluoride. After that, see the next XeF6. XeF6. One xenon and 6 fluorine can link with each other, having the oxidation state +6. Having the oxidation state +6, in which one xenon can link with 6 fluorine atoms to form the structure. For that purpose, see the structure of one xenon and 6 fluorine. This is central xenon atom can link with 6 fluorines. 6 fluorine. First, this is fluorine 1, then remaining 1, 2, 3, 4. 6 fluorine can link with each others. 1, 2, 3, 4, 5, and last one is here, and one lone pair is formed. So this structure of xenon hexafluoride, this structure is the octahedral structure. Octahedral structure of XeF6. That is xenon oxyhexafluoride. Then see the next structures, remaining structures, that is oxychlorides. First of all, that is XeO3, Xenon Tri Oxide. One xenon can link with 3 oxygen, then oxidation state is +6. Then XeOF4, at that time it also possesses the +6 oxidation state. In this formula, one xenon can link with 3 oxygen atom. One xenon can link with 3 oxygen atom. This is xenon. Can link with 3 oxygen atom. This is first oxygen atom, second oxygen atom, and third oxygen atom. One xenon, 3 oxygen atom can link with each other to form the structure, and one lone pair of electron is occurred. At that time, its structure becomes trigonal pyramidal. Trigonal pyramidal structure is formed by XeO3. This is the last structure, XeOF4, having the oxidation state 6. in which xenon is attached with one oxygen and 4 fluorine. Suppose likewise that this xenon is linked with one oxygen at the top and 4 fluorines. These 2 fluorines, then these remaining 2 fluorines. Likewise that structure is obtained by XeOF4, that is square pyramidal structure is formed. So all these structures are formed by the xenon compounds. This is the last remaining point of this chapter, that is uses of noble gases. Then write uses of noble gases. That is, which are the noble gases? First is the helium, neon, argon, krypton, xenon and radon. You may write, see again, concentrately. You may write the uses of noble gases. That means first, which are the uses of helium from the textbook or board book. Uses of helium, then uses of neon, uses of argon, uses of krypton, xenon and radon. This is the last part of this chapter. May write in your notes uses of noble gases. Okay, here total the 16, 17 and 18 groups elements are completed. In next class we will discuss about the new chapter, that is solution and colligative properties. Okay, thank you.